The next chapter, waves. It is a new chapter, that is waves, and weightage 9 mass. Right? Okay. The first chapter, that is oscillation, the weightage of that is 7 marks, and the weightage of this one is 9 marks. Here we have very important derivations. Totally, if I complete this chapter, totally there are 21 marks and here 17, that is 40 marks completed. It is say 40% of your portion. So if you complete only these 4 chapters, you will get a 40 marks and 30 practical. Your score will be 70 in physics. Remember, these 4 chapters I have taken. Later I take a further chapters also. But if you complete only these 4 chapters, you will get a 40 plus 30, that is 70 marks. Automatically you will be in a very good position. Right. Now the concept waves. It is a very important in your higher education also. I have selected such a chapters which are useful for your engineering. In mathematics also I have taken this trigonometry, limits and differentiation, integration, that is continuation of your engineering. Here also waves. Waves means we discuss the things in terms of the waves only. The concept of the wave, it is a very difficult to understand because it is a totally a microscopic wave, microscopic level. In mechanics what happens? If I say it is a motion of a particle, then I can say the bus. But here the particles vibrate. I can't see the vibrations, but how they propagate, that is very interesting. You observe carefully, you are listening the sound, but the waves are propagating, you can't see the waves. But what actually happens, that is the discussion. So in this chapter we discuss about the waves. Okay, now I start the waves. As usual, the first one is concept. Concept of wave and types. This is your subheading. Concept of waves and what is a wave? First you should understand what is a wave. Wave is nothing but it is also a transfer of energy. Sound is also energy. Light is also energy. Light propagates from one point to the another point. Sound also propagates from one point to the another point. It means that there is a transfer of energy. If there is a one bus travels from one point to the another point. If it is in a motion, that energy is known as a kinetic energy. That kinetic energy is given by 1 by 2 mv square, mass and velocity. Velocity and mass decides the kinetic energy. And one can see how the energy transfers. Definitely very common student can tell, common people can tell, if the bus is moving very fast, velocity is more, therefore its kinetic energy is more. And if the mass is more, definitely the kinetic energy is more. We can see this one. But what happens in waves, how the wave propagates? To understand this, I give you one best example. Take the 4 balls. This is 1 ball, second ball, third ball and fourth ball. This is the first ball, second ball, third ball and fourth ball. Now if I apply the force on this, If I apply the force on this, then automatically it moves, the ball moves. These are the 4 balls. This will move. If this ball does not hit this one, nothing will happen to these 4 balls. If I apply the force on this, it moves. But if this ball does not hit this, they will be in their positions only. Am I right? It means that there is no problem. The same one, there is first ball, second ball, third ball, fourth ball. This is first, second, third, fourth. I connect by means of a spring. I connect all the 4 balls by spring. This is what? Your spring. Then if I apply the force on this, what happens? If I apply the force on this, automatically this ball moves to and fro. That is called oscillation. It starts vibrating. This is called vibration. Vibrations are created. So this ball will affect these 3 remaining balls. Observe, if it begins to vibrate, automatically it also begins to vibrate with a lesser amplitude. This also begins to vibrate with the lesser amplitude. This begins to vibrate with the lesser amplitude. It means that all the balls begins to vibrate. It means that which property is responsible for this one? That is, this acts like an elastic. Therefore, elastic property is responsible for the propagation of the waves. Therefore, it is one of the CET and NEET question. Which property is responsible? That is, elastic property is responsible for the propagation of the waves. Once again I explain. 4 ಬಾಲ್ ತಗೊಳ್ರಿ, 4 ಬಾಲ್ಗಳನ್ನು ಸಪ್ರೇಟಾಗಿ ಇಡೋನು. ನಾವು ಒಂದು ಕಡೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ, ಫಸ್ಟ್ ಬಾಲ್ ಮೇಲೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ. ಬಟ್ ಈ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದು ಇದ್ರ ಕಷ್ಟ ಸಂಬಂಧಪಟ್ಟಿರ್ತೈತಿ. ಇವಕ್ಕೆ ಹಿಟ್ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ದೀಸ್ 3 ಬಾಲ್ಸ್ ದೇ ರಿಮೈನ್ ಆ್ಯಸ್ ಇಟ್ ಈಸ್. ಸೆಕೆಂಡ್ ಟೈಮ್ ಏನು ಮಾಡೋನು, ದ ಸೇಮ್ 4 ಬಾಲ್ಸ್ ಆರ್ ಕನೆಕ್ಟೆಡ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಸ್ಪ್ರಿಂಗ್ದಿಂದ ಕನೆಕ್ಟ್ ಮಾಡಿರಿ. ಅಕಸ್ಮಾತ್ ನೀವೇನಾದರೂ ಮೊದಲನೇ ಬಾಲಿನ ಮೇಲೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರಿ, ದಿಸ್ ಬಾಲ್ ಬಿಗಿನ್ಸ್ ಟು ವೈಬ್ರೇಟ್. ಹಿಂದೆ ಮುಂದೆ ಹೋಗಕ್ಕೆ ಶುರು ಮಾಡ್ತೈತಿ. ವಿ ಕಾಲ್ ದಿಸ್ ಒನ್ ಆಸ್ ಆಸಿಲೇಷನ್. ದಟ್ ಈಸ್ ಅವರ್ ಫಸ್ಟ್ ಚಾಪ್ಟರ್. ಆಸಿಲೇಷನ್ ಇದಷ್ಟ ಆಸಿಲೇಟ್ ಮಾಡೋದಿಲ್ಲ. ಸೊ ಇಟ್ಸ್ ಟ್ರಾನ್ಸ್ಫರ್ಸ್ ದ ಎನರ್ಜಿ ಟು ದ ಸೆಕೆಂಡ್ ಬಾಲ್. Second ball also begins to vibrate, but vibrations will be lesser than this. Amplitude will be lesser than this. It transfers the energy to this. It also begins to vibrate. Idhar meginda idhak bartati idvi. It means that all the balls begins to vibrate. It means that because of the spring it is happening. Spring has elastic property. Therefore, CET ಒಳಗೆ ಬಹಳ ಸಲ ಕೇಳ್ತಾರೆ, which property is responsible for the propagation of the waves? Then we call that one as a elastic property is responsible for the propagation of the waves. This is one thing. I give you one more example for this. So, you are sitting here, you are listening my sound. So you are listening my sound means here the waves are created. How? Whatever I speak, here the particles are present in this medium. The first particle begin to vibrate. This particle will transfer the disturbance to the next particle, that begins to vibrate. Next particle, that begins to vibrate. In this way, vibrations are transferred. When these vibrations hit your ear, then you have the sensation of the what? Sound. If you are exactly at the front, the amplitude is more, therefore you get a more sound. So as we move away from this, automatically the sound decreases. Finally the vibrations vanishes. Therefore we say that we are not listening properly. ಈಗ ಏನಾಗ್ತಿರ್ತೈತಿ, ನಾ ಮಾತಾಡಿದ್ದನ್ನು ನೀವು ಕೇಳಾಕತ್ತೀರಿ. ಇಟ್ ಈಸ್ ಅ ವೇವ್. ಎಲ್ಲ ಕಣ್ಣಿಗೆ ಕಾಣೋದಿಲ್ಲ, ಒಳಗೆ ಏನು ನಡೀತೈತಿ. ನಾ ಈಗ ಮಾತಾಡಕತ್ಕೊಳ್ಳೇನ ಫಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇಲ್ಲಿ ಯಾವ ಪ್ರೆಸೆಂಟ್ ಅದಾವಲ್ಲ ಏರ್ ಒಳಗೆ, ಅವು ವೈಬ್ರೇಟ್ ಆಗಕತ್ತಾವ. ಫಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ವೈಬ್ರೇಟ್ ಆಗಿದ್ದ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿಕಲಿಗೆ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಕಳಿಸ್ತೈತಿ, ಅದು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೈತೆ ವೈಬ್ರೇಷನ್ಸ್. ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ಕಳಿಸ್ತೈತಿ, ಅದು ವೈಬ್ರೇಷನ್ಸ್. ದೀಸ್ ವೈಬ್ರೇಷನ್ಸ್ ಅಪ್ರೋಚ್ ಯುವರ್ ಏರ್. If they approach your ear, then you have the sensation of the sound. This is what transfer of the energy. If you are in the first bench, you listen loudly, the reason vibrations are more. Hindgade kuntorge vibrations are less, therefore they listen low sound. Hanga durga hobitra vibrations will die because they are damped vibrations. Finally there is no sound. This is one example. Observe carefully. When the wave is transferring from one particle to the another particle, particles vibrate, but there is no actual mass motion. ಇಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ ವೈಬ್ರೇಟ್ ಆಗ್ತೈತಿ, ಬಟ್ ಪಾರ್ಟಿಕಲ್ ಬರ್ತಿರೋದಿಲ್ಲ. ಪಾರ್ಟಿಕಲ್ ವೈಬ್ರೇಟ್ ಆಗಿ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ವೈಬ್ರೇಷನ್ಗೆ ಕಳಿಸ್ತೈತಿ, ಅದು ಮುಂದೆ ಬರೋದಿಲ್ಲ. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇದು ವೈಬ್ರೇಟ್ ಆಕೈತೆ ಕರೆ, ಇದು ಮುಂದೆ ಬರೋಂಗಿಲ್ಲ, ಬರೀ ಜಸ್ಟ್ ಕಳಿಸ್ತೈತಿ, ಅದು ಇರೋ ಪ್ಲೇಸ್ನಾಗ ಇರ್ತೈತಿ. ದೇರ್ ಫೋರ್ ದರ್ ಈಸ್ ನೋ ಆ್ಯಕ್ಚುಯಲ್ ಮಾಸ್ ಮೋಷನ್. ದಿಸ್ ಈಸ್ ಒನ್ ಮೋರ್ ಪಾಯಿಂಟ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. In wave there is no actual mass motion. Bus adu tana hogtav, but illa here the particles remains as it is. They will be in their own place, but they start vibrations. They are called oscillations. Okay, so these oscillations transfer the energy. Then if they are very large, then we call them as vibrations. Vibrations ಬಂದು ನಿಮ್ಮ ಕಡೆ ರೀಚ್ ಆಗ್ತಾವ. ಬಟ್ ನೆನಪಿಡ್ರಿ, ನಾವು ಮಾತಾಡಿರ್ತಕ್ಕಂಥಲ್ಲೇ ಪಾರ್ಟಿಕಲಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗ್ತೈತಿ, ವೈಬ್ರೇಟ್ ಆಗಿ ಅಲ್ಲೇ ನಿಂದಿರ್ತೈತಿ, ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿಕಲಿಗೆ ವೈಬ್ರೇಷನ್ಸ್ ಕಳಿಸ್ತೈತಿ, ಆದರೆ ಪಾರ್ಟಿಕಲ್ ಮೂಮೆಂಟ್ ಆಗೋದಿಲ್ಲ. ಇಟ್ ಮೀನ್ಸ್ ದ್ಯಾಟ್ ದೆರ್ ಈಸ್ ನೋ ಆ್ಯಕ್ಚುಯಲ್ ಮಾಸ್ ಮೋಷನ್. ಟು ಕ್ಲಿಯರ್ ದಿಸ್, ಒನ್ ಮೋರ್ ಎಕ್ಸಾಂಪಲ್ ಐ ಗಿವ್ ಯು. ಸೊ ಇಫ್ ಯು ಟೇಕ್ ಅ ಸೈಲೆಂಟ್ ವಾಟರ್, ಇಫ್ ಯು ಥ್ರೋ ದ ಒನ್ ಸ್ಟೋನ್, ripples are formed on the surface of the water. So you will find the waves ಹೆಂಗೆ ripples ಗುಂಡಕ್ಕೆ ಹಿಂಗೆ ಹೋಗ್ತಿರ್ತಾವೆ. It doesn't mean that water is moving from center to the end point. No, water particles will be there only, but only the vibrations are created. ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್, ನೀವು ನೀರೊಳಗೆ ಕಲ್ಲು ಒಗದ್ರಿ, ವೈಬ್ರೇಷನ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತಾವೆ, ಅಲೆಗಳು ಡೆವಲಪ್ ಆಗ್ತಾವೆ. ನಾವು ಅಲೆಗಳನ್ನು ನೋಡಿ ನೀರು ಹೊಂಡತಂತ ತಿಳ್ಕೊತಿರ್ತೀವಿ, ನೀರು ಹೋಗ್ತಿರೋದಿಲ್ಲ, ನೀರಿನ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಲ್ಲೇ ಇರ್ತಾವೆ, ಆದ್ರೆ ವೈಬ್ರೇಷನ್ಸ್ ಅಷ್ಟೇ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಿರ್ತಾವೆ. ಇದನ್ನು ತಿಳ್ಕೊಬೇಕಾಗಿತ್ತಂದ್ರೆ, ಇಫ್ ಯು ಟೇಕ್ ಅ ಒನ್ ಬಾಲ್ ಆ್ಯಂಡ್ ಇಫ್ ಇಟ್ ಈಸ್ ದೇರ್, ಓಕೆ, ಒಂದು ಬಾಲ್ ಬಿದ್ದಿರ್ತೈತಿ ನೀರೊಳಗೆ, ನೀವು ಒಂದು ಕಲ್ಲು ಒಗಿರಿ, ಅಕಸ್ಮಾತ್ ನೀರು ಎಲ್ಲ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಮೂವಿಂಗ್, ದೆನ್ ಬಾಲ್ ಶುಡ್ ಮೂವ್, ಬಾಲ್ ಶುಡ್ ರೀಚ್ ದ ಗ್ರೌಂಡ್. ಬರೋದಿಲ್ಲ, ಏನಾಗ್ತೈತಿ ನೋಡಿರಿ, ನೀವು ಕಲ್ಲು ಹೋಗಿದ್ರೆ ಬಾಲ್ ಅಲ್ಲೇ ಎದ್ದು ಕುಂದಿರ್ತೈತಿ, ಹಿಂಗೆ ಹೇಳ್ತೈತಿ, ಒಗದ ಕೂಡಲೇ ಹಿಂಗೆ ಮಾಡ್ತೈತಿ, ಮತ್ತು ಅಲ್ಲೇ ಇರ್ತೈತಿ. ಇಟ್ ಮೀನ್ಸ್ ದಟ್ it vibrates, it sends the disturbance to the next. It means that there is no actual mass motion. Finally, what is a wave? Wave is nothing but it is a transfer of energy. For the transfer of energy, elastic property is responsible. For the transfer of energy, vibrations are created and there is no actual mass motion. This is what concept of the waves. Now we take the types of the waves. Waves can be classified based on their types of propagation. Second one is the direction. Third one is about the medium. Or first we start with the types of the waves. So the heading is types of the waves. Types of waves. In this, the first one is based on medium. Based on the medium, there are two types. Based on the medium, there are two types. One is mechanical waves. And the second one is non-mechanical waves. Mechanical waves are also known as elastic waves. These two are known as, this one is known as inelastic wave. Based on the requirement of the medium. Medium means in Kannada madhyama. If medium is necessary for the propagation means movement, motion. If the medium is required for propagation, then the waves are called mechanical waves. If the medium is not required for their propagation, then they are called non-mechanical waves. For the propagation of the mechanical waves, there must be a requirement of the medium. Medium idrasta propagate agtadi. For non-mechanical waves, medium is not necessary. Without medium also, the waves can propagate. It means vacuum also they can propagate. The examples I can write. Examples for this, one is the sound waves. You can write, the first one is the sound waves. Another one is seismic waves. For non-mechanical, example, light waves, radio waves, microwaves, etc. So this is what about the what based on the medium. Types of the waves. Okay, ಎರಡು ಥರ waves ಇರ್ತಾವೆ based on the medium. ಮಾಧ್ಯಮದ ಅವಶ್ಯಕತೆ ಮೇಲೆ ಎರಡು ಟೈಪ್ ಅದಾವ. ಒಂದು ಮೆಕ್ಯಾನಿಕಲ್ ವೇವ್ಸ್, another one is ನಾನ್ ಮೆಕ್ಯಾನಿಕಲ್ ವೇವ್ಸ್. ಯಾವ ಮೆಕ್ಯಾನಿಕಲ್ ವೇವ್ಸ್ ಮೀಡಿಯಮದ ಅವಶ್ಯಕತೆ ಇರ್ತೈತೆ ಅವಕ್ಕೆ. and it means that they propagate in air, water. ಹಿಂಗೆ ಮೀಡಿಯಮ್ ಇತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, ಮೀಡಿಯಮ್ ಬೇಕಾಗಿತ್ತಪ್ಪ ಅಂದ್ರೆ ಮೆಕ್ಯಾನಿಕಲ್ ವೇವ್ಸ್. ಮೀಡಿಯಮದ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಏರ್ ಇರಲಿ ಬಿಡಲಿ, ನೀರು ಇರಲಿ ಬಿಡಲಿ, ವ್ಯಾಕ್ಯೂಮ್ ಒಳಗೂ ಪ್ರೊಪಗೇಟ್ ಆಗ್ತಿತ್ತಪ್ಪ ಅಂದ್ರೆ ದೇ ಆರ್ ಕಾಲ್ಡ್ ನಾನ್ ಮೆಕ್ಯಾನಿಕಲ್ ವೇವ್ಸ್. ಎಕ್ಸಾಂಪಲ್ sound waves and seismic waves. They are the best examples because they require the medium. Here they do not require the medium. Right. Now I can give you the differences between them. Differences. So I make a two columns for this. One is that is what mechanical, and another one is non-mechanical. Mechanical, medium is necessary. Here the medium is not necessary. The second one is they move with the lower speed. They move with the lower speed. They move with the higher speed. Third one is they may be longitudinal or transverse. Here they are always transverse. Fourth one, here vibrations are present. Here electric and magnetic fields are present. So these are the four differences. Now I take one by one. Already we know about this. What is that? Based on the medium, mechanical and non-mechanical. Medium is necessary, mechanical waves. Medium is not necessary, non-mechanical waves. Examples we have sound waves and seismic waves. Here also examples light waves, radio waves, microwaves, etc. And if you take the differences between the mechanical and non-mechanical, mechanical waves require the medium, non-mechanical waves do not require the medium. They move with a lower speed. Mechanical waves are little bit lower speed, but non-mechanical, they move with a higher speed. They may be longitudinal or transverse. Now the next discussion will come, that time you will come to know what is a longitudinal and transverse. But non-mechanical are always transverse. Here vibrations, we call them as a vibrations. There it moves with the elastic and electric and magnetic fields. This is what one. The second one is, that is Roman 2. I can put a Roman 1 and Roman 2 to understand better. Roman 1, Roman 2. Based on direction. Based on direction. Based on the direction, there are three types. First one is one dimensional wave. The second one is two dimensional wave. Third one is three dimensional wave. Okay, one dimensional, two dimensional and three dimensional. They are also known as a 1D. This is known as a 2D and this is 3D. Three dimensional waves. Okay, three dimensional waves. What is a one dimensional wave? If the wave propagates in only one direction, that is called one dimensional wave. That is only one direction. If it propagates, or you can say in a line, two dimensional wave means wave propagates in a plane, two directions. If the wave propagates in two directions, then we call that one as a two dimensional wave, or two dimensional means in a plane. Three dimensional means if the wave propagates in three directions. That is, three directions means what? It is in a space. Then we call that one as a three dimensional wave. ಒಂದೇ ದಿಕ್ಕಿನೊಳಗೆ ಹೋಗ್ತಿತ್ತು ವೇವ್, ಒನ್ ಡೈಮೆನ್ಷನಲ್ ವೇವ್. ಎರಡು ದಿಕ್ಕಿನಾಗ ವೇವ್ ಪ್ರೊಪಗೇಟ್ ಆಗ್ತಿತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಟೂ ಡೈಮೆನ್ಷನಲ್ ವೇವ್. ಮೂರು ದಿಕ್ಕಿನಾಗ ಪ್ರೊಪಗೇಟ್ ಆಗ್ತಿತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ದೆನ್ ವಿ ಕಾಲ್ ದ್ಯಾಟ್ ಒನ್ ಆಸ್ ಅ ತ್ರೀ ಡೈಮೆನ್ಷನಲ್ ವೇವ್. ಸೊ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದಿಸ್, that is wave example. I give you the examples. Example, waves in a string, they propagate in a one direction. Example, ripples on the surface of water. Third one is, for this example, that is light waves. That is light waves or sound waves. You can take a sound waves also. Now I give you the clarification. This is the second part. If the wave propagates in only one direction, that is one dimensional wave. If the wave propagates in two directions or in a plane, that is called ಎರಡು ದಿಕ್ಕಿನಾಗ ಹೋಗ್ತಿತ್ತಪ್ಪ ಅಂದ್ರೆ that is called two dimensional plane. ಮೂರು ದಿಕ್ಕಿನಾಗ ಹೋಗ್ತಿತ್ತಪ್ಪ ಅಂದ್ರೆ then we call that one as a three dimensional wave. So example ತಗೊಳ್ರಿ, ಒಂದು ಸ್ಟ್ರಿಂಗ್ ತಗೊಂಡು waves create ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ it moves only in one direction. That is one. If you throw the stone, ripples on the surface of the water, ನೀರಿನ ಮೇಲೆ ಅಲೆಗಳು ಬರ್ತಾವ, ಅವು ಸಮತಲದ ಮೇಲಿನ ಚಲಿಸ್ತಿರ್ತಾವೆ. It means that two directions, ಹಿಂಗೂ ಹೋಗ್ತಿರ್ತಾವ, ಹಿಂಗೂ ಹೋಗ್ತಿರ್ತಾವ, along the x axis and y axis. So you can say XZ plane. This is x axis, it is y axis, it is z axis, this is called xz plane. Xz plane ne movement ಆಗ್ತಿರ್ತಾವ. That is called 2-dimensional. 3-dimensional means it propagates in all the directions. For example, I am speaking, it moves in this direction, backward, left, right, top, bottom. ಹಿಂಗೂ ಸೌಂಡ್ ಕೇಳ್ತೈತಿ, ಹಿಂದಿನವ್ರಿಗೆ ಕೇಳ್ತೈತಿ, ಮುಂದಿನವ್ರಿಗೆ ಕೇಳ್ತೈತಿ, ಮೇಲಿನವ್ರಿಗೆ ಕೇಳ್ತೈತಿ, ಕೆಳಗಿನವ್ರಿಗೆ ಕೇಳ್ತೈತಿ. It means that it propagates in all the directions. Therefore, we take this one as a based on the direction. There are two types. One is a 1-dimensional, 2-dimensional, and 3. Once again, based on the medium, there are two types: mechanical and non-mechanical. Mechanical means they require the medium. Non-mechanical, they do not require the medium. And these are the differences. Medium is necessary, medium is not necessary. Moves with a lower speed, with a higher speed, longitudinal or transverse. Now, what is longitudinal and transverse? It is my next discussion. And that is purely a transverse. Here vibrations are present, there electric and magnetic fields are present. 1-dimensional propagates in one direction, 2-dimensional propagates in a plane, and 3-dimensional propagates in a space. Example for a string, and second one is in a plane, third one is in a space. Okay, take one screenshot. Okay. Now, third one is based on the medium, based on the direction. The third one is based on the direction over based on the vibration. Based on the vibrations. Okay. Based on the vibrations, there are two types. One is based on the vibrations, there are two types. One is transverse wave. The second one is longitudinal waves. There are two types. One is a transverse wave and another one is a longitudinal waves. What are the transverse waves? If direction of vibration is perpendicular to direction of propagation. Propagation means motion. Okay. If the direction of vibration is perpendicular to the direction of propagation, they are called transverse waves. Here, if the direction of propagation is parallel to direction of vibration, direction of vibration is parallel to direction of propagation, they are called longitudinal. This is very important. Now I give you the clarification. In transverse waves, the direction of vibration is perpendicular to the direction of propagation. How? I show you. Suppose the particles are vibrating like this and wave is propagating in this direction. So the wave is propagating like this and particles are vibrating like this. This is what? This is direction of propagation. Direction of propagation, and this is what? This is direction of vibration. If the direction of propagation is in one direction and direction of vibration perpendicular to that, then they are called transverse waves. Best example, if you throw the stone, ಏನಂತ ಹೇಳ್ತೈತಿ? ವೇವ್ ಹೋಗೋ ದಿಕ್ಕಿಗೆ ವೈಬ್ರೇಷನ್ಸ್ ಲಂಬ ದಿಕ್ಕಿನೊಳಗೆ ಆಗ್ತಿದ್ವು ಅಂದ್ರೆ, ವೇವ್ ಹಿಂಗೆ ಹೋಗ್ತಿರ್ತೈತಿ, ವೈಬ್ರೇಷನ್ಸ್ ಲಂಬವಾಗಿ ವರ್ತಿಸ್ತಿದ್ರೆ ದೇ ಆರ್ ಕಾಲ್ಡ್ ಟ್ರಾನ್ಸ್ವರ್ಸ್ ವೇವ್ಸ್. ವೇವ್ ಒಂದು ದಿಕ್ಕಿನಾಗ ಹೋಗ್ತಿರ್ತೈತಿ, ಪಾರ್ಟಿಕಲ್ಸ್ ಎಲ್ಲ ಪ್ಯಾರಲಲ್ ಆಗಿ ವರ್ತಿಸ್ತಿದ್ದಪ್ಪ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಲಾಂಗಿಟ್ಯೂಡ್ನಲ್ ವೇವ್ಸ್. ದಿಸ್ ಈಸ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಪ್ರೊಪಗೇಷನ್. ಇದು ಲೈನ್, ದಿಸ್ ಈಸ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಪ್ರೊಪಗೇಷನ್ ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ವಾಟ್? ಡೈರೆಕ್ಷನ್ ಆಫ್ ವೈಬ್ರೇಷನ್. ಎಕ್ಸಾಂಪಲ್ ತೊಗೊಳ್ರಿ, ನೀವು ಒಂದು ಕಲ್ಲು ಹೋಗದ್ರಿ ಸೈಲೆಂಟ್ ವಾಟರ್ ಒಳಗೆ, ವೇವ್ ಮುಂದೆ ಹೋಗ್ತಿರ್ತೈತಿ, ಬಟ್ ವೈಬ್ರೇಷನ್ಸ್ ಹೆಂಗೆ ಹಾಕಿರ್ತಾವೆ? ಮ್ಯಾಗ ಕೆಳಗೆ. ಅಲೆಗಳು ಹೆಂಗಿರ್ತಾವೆ? ಮ್ಯಾಗ ಕೆಳಗೆ. ವೇವ್ ಮುಂದೆ ಹೋಗ್ತಿರ್ತೈತಿ, ಇದು ಮ್ಯಾಗ ಕೆಳಗೆ ಆಗ್ತಿರ್ತೈತಿ. ಬಟ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ಇಟ್ ಈಸ್ ಡಿಫ್ರೆಂಟ್. ದಿಸ್ ಈಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಪ್ರೊಪಗೇಷನ್ ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ವೈಬ್ರೇಷನ್. ಹಿಯರ್ ದ ಪಾರ್ಟಿಕಲ್ಸ್ ವೈಬ್ರೇಟ್ ಲೈಕ್ ದಿಸ್. Here this is what? Direction of propagation, and this is what? Direction of vibration. Direction of propagation and the direction of vibration, both of them are in the same direction. ಯಾವ ದಿಕ್ಕಿನೊಳಗೆ ವೇವ್ ಹಾಕಿರ್ತೈತಿ ಅದ ದಿಕ್ಕಿನಾಗ ವೇವ್ ಹಾಕಿರ್ತಾವ, ವೈಬ್ರೇಟ್ ಆಗ್ತಿರ್ತಾವ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, so if you take a one tuning fork, if you hit with the rubber pad, it will produce a sound. So these sound waves always propagate parallel to the direction of the propagation of the waves. Therefore, if you take a ear and a sound, if you take a one tuning fork, the vibrations they show like this. The examples for this sound waves, they vibrate parallel to the direction of propagation. Example for this, light waves. Here they vibrate parallel to the perpendicular to the direction of the propagation of the waves. Simple, very simple concept. ಏನೇನಾಯ್ತು ನೋಡ್ಕೊಳ್ರಿ. ಟ್ರಾನ್ಸ್ವರ್ಸ್ ವೇವ್ ಆ್ಯಂಡ್ ಲಾಂಗಿಟ್ಯೂಡ್ನಲ್ ವೇವ್ಸ್ ಡಿಫ್ರೆನ್ಸ್ ನೋಡ್ಕೊಂತ ಹೊಂಟೀವಿ ನಾವೀಗ. ಹೋಗೋ ದಿಕ್ಕಿಗೆ ಲಂಬವಾಗಿ ವರ್ತಿಸ್ತಪ್ಪ ಅಂತೇಳಿದ್ರೆ ಟ್ರಾನ್ಸ್ವರ್ಸ್ ವೇವ್. ಎಕ್ಸಾಂಪಲ್ ಲೈಟ್ ವೇವ್ಸ್. ಹೋಗೋ ದಿಕ್ಕಿಗೆ ಸಮಾಂತರವಾಗಿ ವೈಬ್ರೇಷನ್ಸ್ ಸ್ಟಾರ್ಟ್ ಆಗಿದ್ದಪ್ಪ ಅಂದ್ರೆ ದೇ ಆರ್ ಕಾಲ್ಡ್ ಸೌಂಡ್ ವೇವ್ಸ್. ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದಿಸ್ ಸೌಂಡ್ ವೇವ್ಸ್ ಹಿಂಗೆ ವೈಬ್ರೇಟ್ ಆಗ್ತಿರ್ತಾವ. ಇಲ್ಲಿ ನೋಡಿರಿ, ಡೈರೆಕ್ಷನ್ ಆಫ್ ಪ್ರೊಪಗೇಷನ್ ಆ್ಯಂಡ್ ಲಂಬ ಐತಿ. ಡೈರೆಕ್ಷನ್ ಆಫ್ ಪ್ರೊಪಗೇಷನ್ ಆ್ಯಂಡ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ವೈಬ್ರೇಷನ್ಸ್ ಆರ್ ಪ್ಯಾರಲಲ್. ಆ್ಯಂಡ್ ಹಿಯರ್ ದೀಸ್ ಪೀಕ್ ಪಾಯಿಂಟ್ಸ್ ಆರ್ ದೇರ್. This is called crest and this is called trough. Crest and troughs are formed, but illilla, this is called compression. These are called compressions and these are called rarefactions. And here we call them as a same crest and trough. Here we use the word crest and trough. There we use the word compression and rarefactions. If it completes, we call this one as a one wave. This is one wave. This is second wave. This is third wave. So from here to here, it is a one wave. And this is the second wave. This is the third wave, like this. You can crest and trough anta karibeku. ಇವಕ್ಕೆ ಕಾಂಪ್ರೆಷನ್ ಆ್ಯಂಡ್ ರೇರ್ಫ್ರಾಕ್ಷನ್. ಕಾಂಪ್ರೆಷನ್ ಆ್ಯಂಡ್ ರೇರ್ಫ್ರಾಕ್ಷನ್ ಅಡ್ಡೆಲೆಗಳು ಮತ್ತು ನೀಲೆಲೆಗಳು. ಇವಕ್ಕೆ ಅಡ್ಡೆಲೆಗಳು ಮತ್ತು ನೀಲೆಲೆಗಳು ಅಂತ ಕರೀತಾರೆ. ಇವಕ್ಕೆ ಉಬ್ಬು ಮತ್ತು ತಗ್ಗುಗಳಂತ ಕರೀತಿರ್ತಾರೆ. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ ಅಬೌಟ್ ದ ವಾಟ್? ಟ್ರಾನ್ಸ್ವರ್ಸ್ ಆ್ಯಂಡ್ ದ ಲಾಂಗಿಟ್ಯೂಡ್ನಲ್. ನೌ ವಿ ವಿಲ್ ಹ್ಯಾವ್ ಸಮ್ ಡಿಫರೆನ್ಸಸ್. ಯೂಶಲಿ ಯು ನೋಟ್ ಡೌನ್ ದಿಸ್ ಒನ್. You note down this. they ask the differences, sometimes they ask the differences, what are the differences between them. Okay, for that I write the differences. For that, 2 columns. One is transverse, another one is longitudinal. Yes, first one. What is this? I have to write the differences. First one, perpendicular to direction of what? Write it clearly. Propagation and vibration, they are perpendicular. Propagation and vibration, they are parallel. This is first difference. Second one is, here crust and troughs are created. Here ಇಲ್ಲಿ ಎಂತ ಏನಾಗ್ತಾವೆ? Here compression and rarefactions are created. This is the second one. ಅಲ್ಲಿ crust and trough ready ಆಗ್ತಾವ, ಈ ಕಡೆ compression and third. Density changes. Density does not change. All of you know the very interesting word, that is a density. What is a density? Density is equal to mass divided by volume. That is called density. Why it changes and why it remains same, we will see it later. Next point, these can be polarized, but these cannot be polarized. Polarized means you will have that definition in second year. Polarization, there is one concept that is called polarization. It is a phenomenon of restricting the components to the single plane. There we restrict to the single plane. We call that one as a polarization. Then they travel through solid, liquid and gases, but they travel through the surfaces of solid and liquid. These are the what differences. You know, vibration and propagation, they are perpendicular. Here vibration and they are parallel. Crust and troughs are created. Compression and rarefactions are created. Here density changes. Here density does not change. These waves can be polarized because there we can restrict one components to the single plane. Because both of them are perpendicular, we can remove one of them. But they cannot be polarized because both of them travel in a same direction. Here in solids, liquids and gases, they can travel transverse waves, but they travel only in what? Solids and liquids, that too on the surfaces. So this is all about the what? Propagation. That is about the longitudinal and transverse waves. If there is an example, what type of the wave? So if you ask me, light wave, finally, I write it, finally. What is a light wave? Light wave is, okay, you have to write all of three. First one is based on the requirement of the medium. Second one is based on the direction. Third one is based on the vibration. Based on the requirement of medium, mechanical and non-mechanical. Light requires the medium or not? Medium, it requires the medium, therefore light wave is mechanical, correct. So how it propagates? Perpendicular to the direction of propagation. Vibrate perpendicular to the direction of propagation, therefore transverse. And light propagates in all the directions, therefore 3D. This is light wave. If you take a sound wave is, okay, sound wave requires the medium or not? It does not, it requires the medium for its propagation. If it requires a medium for the propagation, then we say it is a non-mechanical. How the particles vibrate? Parallel to the direction of propagation. Therefore, they are longitudinal. Okay. And in how many directions? One direction, two directions. Sound propagates in all the directions. Therefore, 3D. So, this is about the what? Sound waves. So, if they ask about one wave, we have to mention all of three. Based on the medium, based on the type of vibration, and based on the direction, we have to write all the things. So, this is about the what pattern. This is the final discussion concerned with the about. Okay. Once again, I want to repeat all the things so that tomorrow onwards I can write the more discussion about the waves. Yes. How many types of waves are there? What is a wave? Wave is nothing but it is a transfer of energy. Wave is nothing but it is a transfer of energy. Transfer of energy means it travels from one point to the another point. While traveling, there is no actual mass motion, only there is a transfer of the disturbance from one point to the another point. Therefore, elastic property is responsible for the propagation of the waves. Second one is there is no actual mass motion of the particle. This is the first one. The second one is wave can be classified based on the requirement of the medium, based on the direction, based on the vibration. Based on the requirement of the medium, there are two types. One is mechanical waves and another one is a non-mechanical wave. Mechanical wave requires the medium for their propagation. Example is sound waves. Light waves, second one is non-mechanical wave. Non-mechanical wave means they do not require the medium for their propagation. Example for that is light waves. Second one is based on the direction. We have the three types: one-dimensional, two-dimensional, three-dimensional. The waves propagating in a straight line, they are called one-dimensional. Example for that, string. If the wave propagates in a plane, two directions, that is called a two-dimensional wave. Example for that is ripples on the surface of the water. Third one is if the wave propagates in all the directions, then we call that one as a three-dimensional wave or space. Example for that is light and sound waves. Then based on the types of the vibration, this is very important. The last one is based on the vibrations. There are two types. One is a transverse and another one is a longitudinal. If the particles of the medium vibrate perpendicular to the direction of the propagation, then we call that one as a transverse wave. Example for that is light waves. If the particles of the medium vibrate in the direction of the propagation, parallel to the direction of propagation, then they are called longitudinal waves. Example, best example, light waves. Best example for that, sound waves. Here crust and troughs are formed, and here the compression and rarefactions are formed. And finally, if you take the differences between them, the propagation and vibration, they are perpendicular. Here propagation and vibration are parallel. And here crust and troughs are formed, but here compression and rarefactions are formed. In this, the density will not change, density changes. These waves can be polarized, they can restricted to one component, but here they cannot be polarized. Travel through the solid, liquid and gases, but they travel only on the surfaces of solids and the liquids. Suppose anyone asks you, what type of the light wave? What is a light wave? You should say all the three. Light wave is Now, if anyone asks you, then how you say? I am Indian, belongs to Karnataka and belongs to Mudol Taluka, like that. So here light wave is, it is a mechanical based on the requirement of the medium. It is a transverse based on the type of vibration, three-dimensional based on the direction. If they ask what is the sound wave is a non-mechanical based on the medium, and longitudinal based on the vibration. Third one is based on the direction, it is a three-dimensional. So this is all about what today's discussion. Tomorrow once again we will have wonderful discussion about the wave, their wave, the terms associated with the wave, energy associated with the wave, wave motion, so many facts are there. We will discuss that one next class. Thank you.